Welcome to Renaissance Charge videos. I'm Rick Friedrich, and here's another video on my 4-pole dual pole motor. So what we're going to show today is the speed control, water cooling, new MOSFETs, and gate driver circuit, as well as a few other things. We're going to load it down a little bit, not all the way, but we're going to run it at 36 volts today. And I want to go over the particulars with this. We're going to run it off of the small batteries, 35 amp hour batteries, and charge the golf cart 225 amp hour batteries. We're not going to use this generator. This is for another motor, and it has to be, the shaft would have to be on another angle here. What I have is a wind turbine generator, which is not very efficient, but we're going to use that, and we're going to just run a little bit of a load off of that today and charge up another battery. And then we can run the LEDs again. We can run a big fan. I've got this fan here that will drive. So I just want to go over the details and figure it out. So we're looking at these battery voltages here. This one is the charging battery, 37.8. It was at 36, and only after a few minutes of running it charged up pretty fast. So I'm not going to discharge it at this point, but we have these batteries here. You can't see them right now. I have to put the camera down. So these batteries right here are at 35.6 volts, and just going to keep this up so that you can see the oscilloscope. So what we have is the oscilloscope running here, and I'm going to show a couple of things here. Let's just go over timing. So you can see the little LED here is indicating the pulse rate, and we can adjust that to a greater or less extent. So what I'm going to do is, this is my amp meter going off here. So what we have here, this isn't the Arduino speed control yet. We will show that later on. I'm still adding a couple of things to it right now. So what I'm going to show first is my speed control, and there's two adjustments on it, 2 potentiometers that allow you to adjust it. Now with the Arduino, we will have, let me get my face in the picture here. We will have the just one pot on there. We can adjust it. We can set the pulse width and frequency, the pause and the pulse rate independently. But what we do with the Arduino is we're going to set it up so that different RPMs, it's going to have different pulse rates. And it's also going to have a disruptive frequency every 1/10 of a second or so forth for safety, for biological safety, so there's not a constant frequency that will be constantly changed without affecting negatively the charging rate. Pardon my voice today. Anyway, what we're going to do here is show the difference right now as I change this. So we can see the pulse, the frequency change as I change the 150K pot here, and that will slow it down. And then I'm going to put it to maximum on this pot. Oops, wrong way. No, that was the right way. Alright, so now we can adjust the off time more and more. Let's see, that's turned off quite a bit more. And then you can see the LED just blinking slowly. So we'll have a preset low, or you can adjust it to what you want. Now the other thing is the pulse on time we can change also with, there's a 1 ohm or a 1 microfarad capacitor on the speed control that allows it to be set to that rate of, let's see what it is here. It's about 80 millisecond on time is what I have it set to right now. We can change that. And there's a lot of variation in this between those three adjustments. So anyway, that's the speed control. I've just sent out a bunch of these kits here, and I've already assembled the boards for people so they don't have to worry about it. And it comes with instructions. Anyway, the point is that there is quite a bit of adjustment here, which is nice. Alright, so we don't really need to look at this so much. I'll keep it on so that you can see it while we're running it. Alright, so now one of the things that I just did was added some rubber on here, which I didn't perfectly cut out, so it'll look like it's wobbling here. But anyway, this allows for some of the vibration when it goes into resonance to be absorbed, at least on the top plate here. I just ordered another one for the bottom plate. And it also will ensure that the magnets stay in, at least on the top side. So for those who are getting this kit, I would recommend putting some epoxy on there around the edges of the magnets. I ship them with them pressed in already, but I would put some epoxy on there and apply some of this rubber. It's about $12 a piece for each side, so I haven't included that in the kit because it might not be what everybody wants. But anyway, it's a silicone rubber, and it's got adhesive on it, so that absorbs some of the vibration. Now we have a belt on this, so that is not going to get up to high RPM. It's not going to vibrate here. I will run this after we run the load here without it, and we'll see it speed up really fast. Alright, a couple more things. So we have here the water pump and reservoir, and behind it here is a fan on a radiator. And so we have this water cooled, this whole system here. It's not really pretty or anything, not meant to be. So what I'm going to do is show that later on in the video. And right now what I have is the generator coil is shorted out, which means that it actually speeds up the motor a little bit. So we're not going to use generator coils right now. We're going to run the load off of the pulley. And now I do have a separate battery here for the water cooling, and then so the fan and the pump are running off of it as soon as I hook up this one wire here. And that will make sure that it keeps it at a temperature, or appropriate temperature. And then we're going to run the gate driver. The speed control is also run off of this, as you can see it's pulsing. And it's the gate driver circuit is also running off of that. So now the gate driver, I can run, it's really one of the biggest gate drivers we can use. It's a 12 amp gate driver. And I'm going to run one gate driver per set of 4 coil MOSFETs on each, and so I have a separate little board for that here. Alright, so we have here the Arduino gate driver, and this is one we were running. I was running 4 of the gate drivers on it. So it has a little pot, and then it's all programmed already. It's a basic program that we made to run it, and then include a certain frequency for starting and low RPM, as well as when it has no RPM after it's started, then we want to shut the thing down because it's under a needless load that's not going anywhere. So, and then of course we have this disruptive frequency that we've included in it as well. So this is the system as it will somewhat look like. There's twice as much parts on there than what we'll have for this particular model. That's what it will have. Actually a little bit bigger than that for the 10 coiler. So yeah, here's the little gate driver right here. And I got to put it on here first to allow this to drive. I was running it off of 4 coils, or 2 coils. Now I'm going to add the other 2 so I can get in here. Hopefully everything's hooked up right. So anyway, you can see there's one battery coming down a little bit, the big golf cart batteries, because they were charging. So let's reset all this and turn our meters on and off so that we reset. So what we're going to do is start it up. So right now I have a safety switch here on the negative, and I just want to make sure. I don't know if the amps can be seen here. They're at 0, of course. So what I'm going to do is just give it a little self-start under low pulsing, and then let's see what happens here. So I have, you can hear the generator on there. So it's at 16 amps, 33 volts input. You can see it's charging those big batteries really well. I'm not going to attempt to prove how much over unity and so forth, all that is in this video. This is an instructional video, just going over some of the details. Now, like I said, you can see the oscilloscope as I change the off time, opening up. Now we could change so we're almost at 100% on time. I always want to have, actually the faster the frequency with these gate drivers in the MOSFETs, the more charging we get. But we have to allow them enough time to turn on and off, so we can't go up too high. Alright, so what I have here is a battery at 12 point, this is a three-phase generator here. I've got a three-phase bridge as well, and now I've got a 100 ohm resistor, because if I put the straight power output on this battery, it's going to want to fully charge it. It's going to dump as much as it can into it. So I think we can see here, I'm going to start charging it, and you're going to see it go down. So I'm drawing now 17 amps, 19 amps, 20 amps, and I'm charging this battery nice 12.46, 47, and of course this resistor is going to get hot. Not a very efficient generator. Now I'm going to go to 10 ohms. Let's look at the heat on the MOSFETs to make sure everything's good. They're all good. This is very low power. So now we can see it's really loading down. Now, but we've charged up that battery as well. So let's look at the temperature. Whoops! Whoop! I just did a dead short on it. Alright, anyway, these things happen. So what I want to do is check the temperature, make sure everything's good. If I can just not short these wires out. Anyway, you can see what happens on a short. It's going to pull that whole motor over. So let's just check the temperature. Sorry I'm not set up very well here, but this resistor is going to get really hot, so I have to... So we want to see that the temperature is all okay. Now we can look at the 40 volts. It's really charging very well. Of course, it's drawing 36 watts, 36 amps at 30 volts. So it's relatively, low RPM. Ouch. And of course, I've got a lot of losses in this resistor here. It's a 50 watt, 10 ohm resistor. I'm losing everything. Oh well. Ouch, that's hot. So, at any rate, you can see it's charging these batteries pretty good. Now, while I've got the camera on, I'm going to bring the camera over to show some of the details of what I was just doing. So over here, you can see how this is hooked up. And it's a little loose right now because it's going to, if I load it out too much, I'm going to have to secure it better because it's going to pull the whole weight over. But this is just one of these Winzilla 3,000 watt generator. And you can see it's a 3-phase. And then I was running this 3-phase 175, 150 amp bridge. So there's the oscilloscope here. So I don't have these batteries hooked up right now. I have the one terminal at the front hooked up. And so we could run off of those batteries, but I need to, like first of all, I'm just running these batteries right here. So I'm just using jumper cables to connect them together because I was just going through them all. So now what we can do is we can still see that this is charging. So you can see the charging wire here. So there's the circuit. So these are diodes here. And they're two diodes in one going out to the charging. And then these are the 2.5 kilowatt MOSFETs. And I don't really need 8, but I'm going to just do that because I know that people are probably going to try and run it without water cooling, and I'm not comfortable with that. So they need the water cooling on there, so I figured if they go up to the higher voltages, it's going to draw more amperage. So you can see I'm dividing up each coil into two, one MOSFET per half a coil. And so anyway, we're at 13.6 amps. We're already up to 39 volts on the charging battery. So what we're going to do now is run the lights. Now this is 100 watt and it's pretty much at full brightness now because it is fairly high RPM. Now we're going to run this one too. Well, we were going to run that one and I just dropped it. So let's make sure this is all, see we're all good here heat-wise. It's still pretty hot out here. I've got this 400 or 200 watt bulb above me here, really bright, really hot. So we want to look at the coils. So that's a generator coil and that's a motor coil. So 80 is fine. Now I've got these heat shrink tubes on there, which I don't really want because they are going to draw too much. So you can see how bright that is. And that's just one coil. But when I short it, it speeds up. So anyway, we got the water pump here, which is not even on. Got to turn it on. So that's pretty good. It wasn't even circulating the water there, and there's no heat. So I mean, we're not talking about a lot of power right now, because we're only at 32 volts, 33 volts at 14 amps. But there you have it for now. Now what I'm going to do is I'm going to disconnect this and now I'm going to turn down the speed so that we can start up, and I'm going to turn this switch off here if I can do that with one hand. So now what I'm going to do is, I'm going to zoom in for a second here. I'm surely going to get awarded the best camera action for YouTube. I just wanted to not turn it off so that people don't get all complaining. Alright, so now what we're going to do is disconnect this and put the fan on. We've got a big fan here. See if we can not make it take off. I've got to find an appropriate Allen key here. Alright, so this is a big industrial fan. I've shown this running at my conventions with the way it is right now. The last couple of conventions I ran it like this. And then, I didn't bring it down far enough here. So I've also put it in the cage, but I found it's a little bit more involved to bring this to my conventions with the cage, and I did it with a pulley. There we go. I had a pulley on it when I put this motor sideways. So we'll get this running, and this is going to put a similar load on. You can see though that this will draw probably less energy. Well, this particular Windzilla isn't very efficient. So it draws energy without even a load on it, which is what this generator does as well. Most generators do that. So we'll run this again. We'll see the amps. And then let's look at this battery for a second here, see if it's held its charge. So 1241, we only ran that for a very short time anyway. So you can see this battery, these big golf cart batteries have charged up and they're somewhat holding their charge. So this time I'm going to, actually I don't need the water cooling on because we're going to have this fan blowing the air. It's actually going to be blowing downward, so it may take off. Alright, let's get it started here. Hopefully we don't run into any problems. Now I gotta be careful, I don't blow everything away here. Oops. So we're running at 40 amps though. It is drawing quite a bit. Now if we got 55 amps on here. We got nice temperatures on MOSFETs. That's quite a bit of air blowing down here. So it's drawing quite a bit off these little batteries. 48 to 53. These batteries are going down pretty fast though. So let's bring it back down. So you can see we're charging pretty good though. So it's got a pretty big pitch to the fan here. So the air is just coming out. Now, I'm not shorting the coils out, which I could do. They are still running. So now, we've shorted the generator coils out because I was running them, and now we're running more efficient. So anyway, we're good here without even the water cooling. Now I could run this off of the big batteries. We could try that. So what we'll do, we'll let that come to a stop. You can see the batteries here charging, discharging and charging. So what I'm going to do is disconnect this, and then I'm going to hook it up to 36 volts. Yeah, it's going to take me a couple minutes here to do this, so I need a wire to go from the back to the front. So what I have here is it connected, and this wire is getting quite warm because it was running So what I'm going to do is connect up the negative to the positive terminal here. We can look at this in a minute. This way the battery voltage will be nice and high. Of course my charging voltage is pretty high already. Alright, so now what we're going to do is take the negative wire off of these other batteries and connect to this battery. Then this thing is going to really rip. So I got a fairly long wire here that we can run. Of course, you've got your losses in your line. Rick, what are you doing? Alright, so now we're going to come to the furthest most negative terminal. So we were doing 60 amps, which is what I usually do, 24 volts with this fan at my convention with those little batteries there. But now we got 225 amp hour batteries. And oh, now I've got to tighten this wire as soon as I can get this bolt out of here. So, of course this video is going to win the awards of taking more time, as one guy wrote, Rick, you take more time than you need to in your videos. Well, that's just too bad. That's all I got time for. Alright, so we're going to hook up this battery, or this meter, as soon as I can find the negative terminal. And I'm going to connect it up here. Somewhere. I think I'll use this little wire. So now we've got 36 volts. It's going to draw a whole lot more. It's going to produce a whole lot more, I should say, power, because it's not going to be a big voltage drop. Alright, so now let's look at this again. So we're at 36.7 volts at rest. These batteries have been resting for a while. And now we're going to start the motor again. So what I'm going to do is give it a self-start and then look at the amperage. I mean, I'm not really worried. I got 8 MOSFETs on there and they're not overheating. So you can see there are about 35 amp pulses, at least with this meter. So you can see the voltage drops going down to 33 volts, and we're at 68. So now we need to do even though we need to do the water cooling, because I could see they were getting a little warm there. So let's cool them off a little bit before we do this again. See, we were at 100 Fahrenheit, which is not much, right? I mean, that's 40 Celsius. We want to look at the gate drivers too, that they're not getting too hot. They shouldn't. So anyway, that's that. And we can get up there again and start this thing up again. So now that was starting it at full speed, which I forgot. So now we're starting to create a lot of airflow in this room. So you can see, we'll let the voltages stabilize, and so one thing I should look at is these bridges. They are actually at 100. They are the ones that are getting hot, actually. It's not the MOSFETs as much as... So I do have a... Let me bring the camera back here again that we can look at it. So again, just to go around here, I just hooked up this battery back here, and this is the furthest most negative terminal. And what we did, oh yeah, so these are 60 amp diodes, like I said, on 30 on each side, and they are really producing for me. In other words, I am charging very well with this setup. And so you can see quite a big voltage drops there. That we had about 80 amps. At startup it was probably 100 amps. And then it went down to about 60 or so. And we were running this big fan. So you can see the pitch in this fan here. You know, it's a pretty big load. So again, I was running the fan, and may need to make a bigger radiator on there, which we have on the big motor, the one that's the double, and then we have some thicker heatsink too. But what this is the water flows through these heat sinks here, and I've got it thermally coupled. And so anyway, you can't go wrong with big diodes on here. You know, we could even put bigger ones on there, or use one of these for each MOSFET, because they're really putting out. So the idea again is that we have one battery bank powering the motor and another one charging. So in this case we've got 36 volts, and we were starting with these batteries, and now we went to these batteries, but it's sitting at 38.4, and it was at 37 when we started, so 37 something. So let's see, I think that's all I wanted to show. I didn't really have time to do everything I wanted to do in this video. I was going to load it down to 4,000 watts, but I didn't really have, well, I didn't get up to 48 volts here. If we got up to 48 volts, we could do that and really draw some power off of this motor here. So, oh yeah, the other thing I was going to mention, I mentioned in my last video, is we have to use this isolated battery for the gate drivers because there's so much noise on the line, so to speak, from the coils, and you really can't risk trying to run it off. I could do it on the small motor if we don't do too much on it, as I said in the last video, but even then people are still blowing them out. There is just so much power, excess power flowing everywhere, that these gate drivers are very sensitive and they will blow out. So even without doing any of this exotic stuff, if you read the data sheet, you'll see how sensitive they are, and the gates of the MOSFETs as well. So this is one reason why I haven't really gotten into doing this over the last 4 years. I wanted to do this and I never got around to it until now. And then it's worked out really good though. It's been very, very good charging, very efficient motor. And so now it's just a matter of playing around with this with the various frequencies. Like I said, this capacitor here, we can go down, so the lower we go on that, the shorter the on time will be. That's C3, capacitor 3 in the circuit. And so I think we want to do that more now that the gate drivers are working out with the isolated battery that we're not driving. Now we are sharing the negative. You can see the negative is coming here, and so we have to share the negative here because we were driving the MOSFETs, and they have to have the shared negative. So, but we can't use, before I was using 12 volts of the input battery, and that just wasn't working out. So it made a big difference. But now we can actually speed up the frequency and get more what we call disrupted discharge, EMP events, so to speak, and really drive this thing hard. Well, I mean, not drive it, really charge. Get more charging out of it and get more efficiency out of the motor itself too. So in other words, there is a timing disc inside of the motor in which there's an on time on this, there's a gap with a timing plate that's about 40% on time each coil out of the 360. We've got 8 magnets passing, so for every magnet it's it's on for 40% of the possible on time. So then within that window we are breaking up the pulses with the speed control. As you could see, we were at 80 milliseconds, and then so we can bring that down to the microseconds and really let this thing pulse hard. So then we're going to create a higher frequency, which then again is going to create more potential. Like we'll have more negative energy, and we can do, like I showed in my last video, a lot more along the negative line, just like Tesla's one-wire system. His lectures, he talked about that. So I think that's all that I wanted to say today. This shows you all the different improvements. And like I said, here's a close-up of the rubber. So you can see I didn't really cut it out perfectly, but you can see the magnets just underneath there. Yeah. So thanks for watching, and we'll do the big motor next, and you'll see that either here or at our other location. Thanks for watching.